everyone. Monday night, and this is the Philosopher and Physicist Hour. Actually, I think it was the Physicist and Philosopher. Either way, it's still
It
two
doesn't
P's.
matter.
So, how are you, Dr. Albers?
I am under the circumstances, I'm okay.
Doing okay. And
Yes.
yes, well, I
I
just
can
want to.
still smile.
You do.
Let's
You have
put
a
it that way.
beautiful smile, and that's
Thank
what people love.
Mhm.
Hello, everyone in the chat room. Hello, all the moderators. How are y'all doing? So it has been really hot here, Claudia. I mean, like Africa hot. It's been hot.
Really?
And yes, yesterday we got up to 98 here.
Oh my goodness.
Yeah. So June has been so far, we're heading for the hottest temperatures ever. But who
That's
knows?
unbelievable because you have such cold weather in winter.
It's a myth. It is a myth because I can tell you, this started last fall.
Mhm.
We and you can go back and look at the records. We started having this 10 to 20 degree above normal readings. Now we would have short pockets of very cold, but then it would be replaced again with 15 to 20 degrees. In fact, in February, it was 31 degrees above normal here in the Front Range in Colorado.
Oh my goodness.
So down in the southwest part of the state, they're in exceptional drought. In fact, 3/4 of the state of Colorado is in some stage of drought. So yeah, it's been very interesting about what's going on.
Yeah, that's amazing. But, I've written about the fact that we can expect our planet to keep warming up because there's just more energy coming from the core. Because the core is just generating more energy because the stellar cores are just pulling the energy out. And the way they pull is very interesting. All they do is their own gravitational field overlaps the Earth's gravitational field. And theirs is very small. That's why they have to come very close.
Go ahead, continue.
Yes.
I'm sorry, Hannah.
I'm sure I sent you the articles where I show how that occurs, that two particles always have to share the energy inside them, and that's the photon energy inside them. If their gravitational fields, which is like the clothing, interact, overlap, then the energy is shared, so they end up with the same. And the same thing will happen with planets.
Yes. And with the planet itself. So I thought of you immediately when this came up today. Boater dies after sinkhole creates a whirlpool on the Arkansas River. Now, this article goes on to say that this is not normal. And I'm going to digress here a second. Mythbusters, that used to be on television, was a great show.
I've watched that show.
Yeah,
I used to watch it in South Africa.
Well, I actually met Adam Savage. Yeah, he's at the United Club in San Diego. Anyway, they showed by the whirlpools at the bottom of the piers of the Golden Gate Bridge, and they have them there constantly. And the myth was, could a person drown or could a boat be sunk into a whirlpool? Now, they showed it would be very difficult for a boat to be pulled in, and even a person, you would have to have a very strong vortices going on. Apparently, this guy was in I think he was in a kayak. Yep. And died, Claudia, drowned, couldn't get out.
Oh my goodness.
So here's the Arkansas River. You know what my first suspect was, something's going on the mantle here.
Yeah, what happens is the Earth's surface is breaking open. That's why over the years, and it's been a few years already, we have sinkholes and fissures appearing. And the reason for that is because the Earth's photon energy or gravitational energy is dropping. And when that happens, the Earth increases in size. So what happens when something increases in size? It breaks open.
By the way, just as a little caveat to that, today the solar wind hit, and I haven't ever seen this. I haven't seen it when it got down that low. It hit 250,000 kilometers. I've never seen it at 250. I've seen it at 3, and I've seen it a little bit underneath 300 kilometers. Claudia, that is a very weak pulse.
Indeed, the sun is getting weaker. But I've been writing about that for a long time now.
Yes, you have. Yes, you have.
The sun is getting weaker. It is dying. And that's one of the things we would expect. And then the other thing I've written about recently is that the Earth has actually moved away from the sun. Then there is another thing, and that is there are some very large stellar cores, some about the size of the sun. They have a lot of mass, but they don't have a lot of gravitational influence on the sun because they're low energy. But they are huge. So when a huge object like that eclipses the sun, what happens is we wouldn't feel the solar wind, at least for a while, because it's just covered, in front of between, if it's between the sun and the Earth, and some of them are huge. They may not do much except cause the sun not to be seen from Earth, but we have the sun simulation system that covers that up. But then they won't allow the solar wind to get through as well. And that may be one of the things that's occurring.
Well, like I said, what we do know just by the empirical evidence alone of the data is that this is, if it was a human being, you would really have this patient on life supports because his pulse rate or hers is very low. So I have a special treat for you, Claudia, and for everybody else. And let me pull this up. So you can see that, right? Okay. So I went into my archives because the question came up with a friend. It was Jeff, actually, on the sun simulator. He doesn't, believe that there is such a thing. And so I went back into my archives of the International Space Station. Now, you can't get this camera anymore. This camera was funded by the European Space Agency. And I'm going to let this play, Claudia, while you and I talk. And I want everyone to be able to see something that our perception of what our solar system is, when you start looking at it and then you look at what it's supposed to be according to the data, to the science, there is a real dichotomy of evidence going on. And I'm just letting this play just very slowly so you and I can just talk because it's going to be quite spectacular.
It's the enormity of what is happening in our solar system, in the inner solar system, to the sun and to the Earth it astounds me all the time because I keep discovering that it's larger than I thought it was. And the fact that they have managed to hide all this from the Earth's population is unbelievable because it is a huge, huge thing that's happening.
Well, let's go a little bit more in depth on that while we're watching this. So, by the way, everyone, the sun is about to come up.
We have so much that's being hidden from us. In 1947, one scientist came up with the idea of electrogravitics. And it was after this that, or around the same time, that reverse engineering of technology started.
They have
objects there reverse engineered objects. That's one of the things they try. Look at that. That's the sun simulator.
Yes. Well, they say it's the sun now, but it's going to get even more weirder. So
how is the sun? How does the sun have a dark halo around it? That is just not possible. Oh my goodness, the sun is supposed to be spherical. Well, it definitely looks spherical on SDO images, and it looks spherical from the surface of the Earth for thousands of years, but it doesn't look spherical there.
No, it does not. And this camera is designed for filming the sun. And I'm going to let this play because, in fact, you can see right down here. This is part of the International Space Station right up here.
Yes.
So I want you to pay attention, Claudia, as we go on, and everyone in the chat room, check this out, this object right here now. Now, for a lens flare, you would have this distortion, which would be normal. Mm-hmm. It has exactly the bright obfuscating light, and then it begins to have a back refraction on the lenses, et cetera, et cetera. So this is normal. This is not.
But even the lens flares that we are seeing are not normal.
No.
Because lens flares, like I've said from the beginning, of secondary images of real objects. So lens flares should have edges and outlines just like the object that is producing them. But these are indicating that the object producing them has a hexagonal outline.
Did you see that also, how it just pulsed? Yeah.
The flashing, the pulsing, yes, I definitely saw that.
Yeah.
And look at this line here. This is not, look how the edge is so well defined.
Yes.
This looks like a laser beam. It doesn't look like a camera effect at all. It wouldn't be so sharp.
It's weird, isn't it?
Yeah, and you can see this line, it looks like what is happening is there's actually a laser beam coming from the direction where the camera is, and it's pointed at something, at the source of the light itself, as if it's like a screen.
And that's some of the things that, and like I said, and just for everyone, I'm sure you can see the reference point in this. This was August, I think, 18th, 2016. So now we're getting some really interesting distortion effects again. And I have I can tell you just a number of these sunrises. Yeah, and it's weird, Claudia.
Just one thing tells you cannot be the sun. Let's even forget about the shape of the lens flares, which tells you that this cannot be the sun. Because a lens flare from the sun would be a circle.
It's
and
supposed
we
to
have
be
hexagons as lens flares. But the sun is a source of light. What we are seeing here is space around the sun darker. Darker space around the sun. That's impossible.
And let me just point this out for everyone.
To be brighter, not darker.
And how we can prove this, look where the light rays are coming. And if this was an obfuscation of the camera, it would obfuscate the light, and the light would be coming out from behind it, not in front of it.
Exactly.
So
it's in the background. It's part of the background. And it looks like this is a kind of a mirror thing where part of it is a mirror where laser beams are shined upon it.
There we go again. Now look at the plasma reaction happening now, Claudia. Look how it's changed even here.
Oh yes, it changed to pink.
Now let's turn green.
And didn't you once show a picture of the sun in the atmosphere? I think it was you, where there was a pink laser beam right through it. right? Seen from the surface of the earth.
Watch this. This is
What?
another, you see, this is what I've often baffled myself with, that we're seeing what appears to me to be a plasma reaction.
It definitely is. I
Now,
think they are powering this thing, which obviously is in orbit, from the ionosphere. And the way you connect to the charge on the ionosphere, which a lot of energy in the ionosphere, is through laser beams. A laser beam can take energy right from the ionosphere to wherever you want it.
I agree.
It's like an electrical circuit. So I think that's why we see that laser beam. Basically, they're powering it from wherever they're getting that the energy source. And they're using plasma, obviously advanced technology they've come up with that we don't get to see on Earth, because they're using more advanced, but possibly 50 or 100 years in the future kind of technology, whilst we only given, the little crumbs.
Well, I think that this is, and we're getting, this is just to let everyone know, it's about 16 minutes. But again, our object here has no relationship to the sun itself.
Mm-mm.
And this is really odd because, here's the thing. This is outside, and watch what happens now as the sun begins to ride. And I want you to begin to pay attention here now to what happens to the Earth. And I'll let the video just start to play out for you. The sun is doing some really strange things if it is in fact the sun, and if it is in fact shining down on the Earth. Now, we all see the sun, right, Claudia? From wherever we are in our position on the globe, wherever we are.
Mm-hmm.
And, you could say, well, the sun would then have a beam of light down there. No, the sun is dispersed because of our atmosphere, right? And we can see, again, this reaction in the background of what the sun is now. The sun should still have its brightness here, Claudia. Look what happens. We've got dark space behind here. Now look at what's happening down here on the planet. Is that just not getting weird? Look how the sun is reacting, Claudia. Explain how that is working.
We have two light sources shining onto the Earth. We have the real sun, which is most likely in the distance, and we have this object, and it's illuminating part of the Earth. And that's why we start to see this different coloration as well in the clouds.
And again, I don't understand how something as bright as our sun, our star, that is right up here, folks. This is where it is. I'm pointing the arrow right up here. Claudia, we shouldn't be able to see anything back here except the illumination of our star, right?
Mm-hmm.
Now, watch what happens down here. These become alive. It gets weird. That's all I can tell you.
It is because...
Now, see here. Watch this, Claudia. How is that possible? It's making a star on the surface of the freaking planet. Look at that.
Yes. You see,
how is that possible?
That's the holographic projections that they do in the atmosphere. Oh my goodness. So that's how they are doing it.
Now watch what happens here to this, whatever it's doing in the atmosphere, it comes alive. Watch that. They move.
Yeah.
They react to whatever that beam was that came down. Now look at them. Look at them.
Yeah, I can see it.
They merge together. Now, I don't understand what this is still. I have not figured out what that is because it's not our sun and it's not anything. But don't get to pay attention right here. Look at that. Watch it. They come up, they come around. And they only started appearing after that beam of light, whatever the hell that thing was. Look at that.
Oh my goodness! It's a projector. They doing three-dimensional holographic projections onto the clouds. That I know, but this thing is actually what's projecting it.
Is this just not phenomenal footage?
That's amazing.
And whatever is going on here, folks, I don't know what these are, but they only entered in once that beam come down. And I'll replay the beam again, Claudia. I didn't want this to see. Watch them. Watch it. Watch that light now. Watch what happens. Look at it.
Wow.
It's just so weird.
Mm.
And it's intense light.
Yeah. You see, this is why they need the chemtrailing, because they've made our atmosphere extremely conductive. So they can do these plasma effects within the atmosphere. And, you know,
look at this one over here, folks. Did y'all see that one? Claudia, that's
amazing. That's just amazing. I actually didn't know. I know they were using a holographic projection onto the clouds, because I sent you one of the articles where an airplane flies right through a cloud where the sun's being projected. I'm sure you saw that.
Yes, I did.
And this is what it is. You know,
I want to stop here.
How they are doing it.
Look at what's happening here. I'm contending that we're seeing a sun that is showing an eclipse.
Oh my goodness.
That's what my contention is, because this does not make any sense. It has no relationship to the sun. And again, this is normal how the sun would disperse its light upon the earth.
Yeah, that's normal, but what they're producing in the clouds is not. And it's not just a holographic projection. They have some kind of lens system that makes it look a lot larger from the surface. So there's a whole lot of things they are doing through this plasma technology that they have, plasma beam technology.
Did you see that?
Yeah.
They just dart. And again, I am mystified, Claudia, how we can have no stars, because I wouldn't expect to see any stars with the sun in the picture. But the sun is now, it doesn't make any sense.
Well,
and look at this.
The background will be dark around the real sun. If you were to, outside of the atmosphere, if we look out, we should see black space, and then we should see the sun. It should look white.
Look at this, Claudia. Look at that. When you talk about a laser beam, that's what I get the idea that they're pulsing photons, whatever you want to call it, plasma, just the way that it reacted, and it's almost played out. Now watch what happens here. Here we have another strange reaction to what I guess is the sun. Look how bright that's becoming.
Yeah, that's very strange.
Doesn't make sense, does it?
Well, with all the chemtrails in the upper atmosphere, it's made the atmosphere very reflective. That's one of the ways they don't let us see what's outside the atmosphere, is by doing that. So I'm
going to go back to where we actually saw the beam come down, because
I can see that there. And it's just, you see how the clouds are moving, and that bright spot is not moving. It's staying right there.
Yeah, it is. It's and again, the pulsing that we get. So I believe this is where we're coming up on this. It's the strangest thing. It's almost like something was projecting down on the atmosphere of the Earth.
Yeah, there was definitely a plasma beam aimed at a region or spot in the Earth's atmosphere.
Here it is.
So there we are.
All right, so I'm just going to stop this, Claudia. And so now we're beginning to see this form, whatever this is. I keep on looking back here. Doesn't that look weird?
Yes, it does. It looks brighter than everywhere else.
So here we
And
go.
it's not the only place. There's that one that's just not moving.
Look at this.
Wow.
So this is just.
So this is how they produce this holographic projection in the atmosphere. Is this object that's in orbit just beams down into a spot in the Earth's atmosphere onto a cloud, and it generates this holographic projection.
Would there be, I'm seeing energy, right? We're seeing photons. So there has to be heat generated by it. No?
Not necessarily hot. Not necessarily hot, because they could be using it doesn't have to be hot. You can have lightning that doesn't emit a lot of heat. You can produce light without heat.
Okay.
I think it's probably what they are doing here. It's like projecting a movie onto a screen. The screen itself doesn't have to get hot. It looks very bright. It can look very bright without getting hot.
Okay.
So I think that's possibly what they are doing, because otherwise we would get very strange effects in the atmosphere if the sun was actually being produced in the atmosphere. I don't think it can be hot like the sun is hot.
Did you see what happened here after that? This comes alive. I mean,
yes.
I don't know what we're seeing, but there
may be some heat associated with it, but not the kind we get on the Earth's, on the sun's surface. Definitely not.
Look at this. And I can't help but not think that that's a round point, because you can see it has it here and it's going around the perimeter.
Yes.
And then we get the crazy reaction. Now, I have another piece of evidence that would show that the hologram, which I think is sometimes in evidence. What if I was to show you a rainbow that was permanently in the atmosphere?
Wow, really?
Yeah, so here we go, and I'll just stop at this. Now here, whatever's happening here, these react, and they're doing something in there. You can see they get intense.
Mm-hmm.
It's a reaction of some kind. I'm assuming
Definitely. Where there is brightness like that, there has to be some form of energy. You don't get brightness without there being a reason for the brightness. There has to be a source of that energy.
Look at this, Claudia.
Yeah.
I don't understand this.
I don't either, because it's not even moving with the clouds.
And look how the light here, it's so if this is a lens flare reacting from our sun, we shouldn't be able to see this. This almost is like it's coiled.
Yes. I think that's possibly one of the sun simulators in the atmosphere, or above it, or at low Earth orbit or something. Look at that. It's not moving with the atmosphere, that's for sure.
No, and we're getting the strange reaction. Now, these are mountains. I can only imagine if someone is around here on this mountain, they probably thought that they saw God, because there is some crazy stuff going on in the atmosphere up here. Lights are just dancing everywhere. Here, look at this, and then it gets bright over here.
Yeah, but it looks different from the surface, because it's not just the light. They somehow create a lens system below those lights. So it looks different from the surface. They've obviously devised a way to simulate the sun for, for the different regions on the Earth.
Yes.
They've devised a way, and I think we're seeing it in operation here.
I think we are too.
It's unbelievable.
Now, I have one other piece of evidence for you that I think that I love it when you're having a chance to actually watch this as we are. Mm-hmm. So let me get the rainbow, and that one, give me 1 second here. I have so many of these. It's kind of like going, I need one of the Dewey Decimal Systems. It's like, could I please get some clarity on my videos? Here we go. All right. So let me pull this one up for everybody. All right. So this is, again, 2 years ago, 3 years ago on the ISS. So here we go. Look at this, Claudia.
Oh, yes.
Watch this. Again, we have...
That's not a normal rainbow. That's the first thing. A normal rainbow forms an arc.
Look at this.
And that is definitely a refraction effect. And that's evidence of the lens systems that they are producing in the atmosphere that are refracting light and causing effects like this.
Isn't this odd?
It's unbelievable that you actually have footage of this from outer space. Well,
yes.
It's not actually outer space because the ISS is in low Earth orbit, but this is unbelievable.
It's fascinating, isn't it? And
fascinating.
It makes me sometimes question, what are we seeing? And I watch as it emerges from the clouds. And this was what was so strange, was that, look at that.
Oh my goodness.
You see,
it's obviously some kind of projection from a satellite
that
is producing that. Look at that. It's not moving within the atmosphere.
No.
So I would say it's being produced from an orbital platform that's moving with respect to the Earth. It's not in the atmosphere. And it is projecting that onto the atmosphere.
That's what I was thinking. And I haven't found the phenomenon again, these cameras.
This is amazing.
Look at that.
Wow. This is evidence beyond anything I expected.
And
I've been writing about these things.
You have.
For years.
And this just shows you where most of the anomalies that I was able to capture back a couple of years ago, most of all of this happens when they start getting close to Antarctica. It's where these phenomena, look at that. Wow. You can see that and here it looks like it's casting a shadow.
Oh, yes. I can see that.
And that's just and look at this. You can see it. And this is near Antarctica. So.
Okay.
I'm telling you, there's something going on down there.
Oh, my goodness.
I just thought you would enjoy this.
This is unbelievable. I am so amazed at this kind of evidence. I mean, I knew this was going on. To actually see it from space, from orbit. Oh, my.
And they're not, they're just pointing the camera.
Fascinating.
It is fascinating. It leads one to believe that there's things that I was talking to one person today, and I said, it's amazing how I think they're hiding it right in front of us.
Yes, hiding in plain sight.
Yes.
I've come across the same idea, specifically with that one that I wrote about this active object in the HI2 stereo A images.
Okay.
Which some people were saying is Jupiter. There's no way it is Jupiter. Because, I mean, we would see Jupiter doing that all the time, but how come it only does that when it gets to that point? That it cannot be Jupiter, it's something else. And it's something that they are tracking, that it's just they're keeping the camera pointed at it.
And this is what's so odd. This actually grows in intensity. It's like it's being
Look
projected.
at that.
And so this is in front of the space station. So we're getting the same view. And here you can go. We're seeing exactly where it's coming now. It's crossing South America, going into what they call the dark zone. They say they can't send a signal over Antarctica because of the positioning of the satellites. I say I don't believe that.
I don't either.
I don't either. I ain't buying that for a second, Jack. And again,
they
look at
just
here.
don't want us to know or see what's there.
So now I have one other one for you. Isn't this interesting, though?
This is so interesting, Wayne. It's fun. It really
is
fun to see these things. I mean, we know they are there. It was a huge and obviously artificial, because you don't get rainbows in that straight line format, not natural rainbows.
So we were talking, I'm going to pull this up so we can see this. So this is one that when I knew that what I felt we were moving into back in when the system, and this is only my hypothesis, that we began to see the first effects of this system. And I think that was back in 2015, may have been a little bit earlier, but this is the ISS.
Wow. Yeah.
Same sun that we saw earlier.
Yeah. This is the sun that when I first saw it for the first time, I said, how can they even expect us to believe that that's the sun?
Yeah.
It's so obviously artificial.
And again, the lights, folks, this is in the background. How does that happen?
Exactly.
Look at that. And the color, the rose color.
Yes.
Just everything was in this rose-colored light. Everything on the ISS that we see from this camera is bathed in this, I don't know.
Magenta.
Magenta. That is the color that is quite beautiful, but quite frightening at the same time.
It is. I think the plasma that they are using produces this kind of color. I think that's what it is.
Now, I just wanted to show everyone this was legit. This was the website that it used to be up on. And so this was phenomenal. What could cause this, Claudia, for light to be a magenta color?
Well, obviously they're using plasma. Plasma means they have some kind of gas that they ionize through basically high electricity. And when it's ionized, atoms are stripped of electrons. Electrons go in one direction and the positive ions in the other. And then now and then some of the atoms recapture electrons, and when they do, they emit a photon. And obviously this particular gas emits a photon that is in the magenta light range. In other words, magenta has to be a red and a blue mixture. So it's emitting red and blue photons.
So this is why we're getting this odd purple that it just, by the way, did you see the plasma jet that came off of the frame? I'll go back up on these. I just wanted to show everyone the stills.
Mm-hmm.
So this was a real natural light that just got everything in this strange, crazy color. And again, how the sun...
So artificial, Wayne, that to tell you the truth, when I see this, and look at the hexagonal lens flares.
By the way, I just want to show everyone How do you get two suns?
When they both simulators, two sun simulators, obviously.
Listen, either one is or one isn't, or they're both are not, or they both are.
They both cannot be because there's a dark outline around both of them, and the sun cannot produce that. The natural sun cannot. There's also a light beam through both of them, which means they actually are the same artificial device, or just, a double.
Mm-hmm.
There are two of them there. And that's basically what it is. You can see they are the same thing. It's just one is emitting more light than the other. But they seem to be working in the same way and powered in the same way. That's why we see that
So
beam.
did you see that light? That's what, you can only get this when you break the steels down. Look at this, Claudia.
Yeah, it's amazing.
It is
that
just
vertical beam right through it. That's either it's beaming energy out or there's energy being beamed into it. That's basically what it is.
strange, isn't it? Now, I wanted to get to, now here's the UFO I caught. Watch it as, I'm going to reverse it.
Wow. Look at that.
It actually rotates. So check this out. So this is even after it's passed and it's still got everything. I want to show you the plasma reaction. There it is. Do you see it? Right here. Watch. Here's the jet.
Oh, yes.
And you can see, and we'll just go in reverse.
Wow.
There it is. Isn't that weird?
Wow, that's very strange. And definitely there's a hexagonal shape there. You see how many straight lines there are in the edge of that thing as well. Definitely a device, and definitely having, as you say, a plasma reaction there.
Having something.
Explodes out of it.
So I have another one I'll show you. I thought that you would just find some of these interesting.
Oh, yes. I'm very interested.
So here is one that when I tell people that they're using an artificial device, this is what I mean. Let me go here. And so people can really see that reality is altered for us.
Mm-hmm.
I really do believe that.
Yes.
So this is the one of the, I don't know if it's the onboard simulator. All we do know is that this is plasma beam or something, laser, something very intense hitting the screen back here. And they actually had a meltdown in space. I mean, it started dripping material.
Yeah, it does look like it.
Yes.
Yeah, that looks like a laser beam being shined onto a rectangular screen type of thing.
And here you can actually see how it's breaking down. And I did a complete analysis on this.
Yes.
But I want to show everyone what a simulator also looks like. So this is the sun. Again, coming right at Antarctica. Watch what happens here, folks. So this is a simulated device. I don't know what they do with this device. It gets pointed at the sun, and then there is a opposite reaction on the station itself. So here it is. They are now right at the bottom of the world. Watch what takes place. This gets very interesting. Okay, here we go. Pay attention to this material. Watch what happens. They're getting ready to do their experiment. Here we go. Watch it very closely now. That block I told you, look what happens to it.
Oh my goodness.
Look at that.
Woo. That's very intense light there.
Watch. And then they turn it off. Is that not just the weirdest thing, Claudia?
Oh my goodness.
Here it is. I don't know what they're doing up there with this
I
material.
think they're using the ISS to do something, or it has something to do with the simulation of the sun. They're obviously using it for some purpose to do with that.
And here we get blue.
Wow. Look at
Everything is blue.
Yes. They're definitely using a blue laser beam in this case.
I mean, this is the stuff that people try to tell me that, well, you know, Wayne, sometimes your thoughts are out there, you know. Yeah, folks, because I've been out there and it's not normal.
No, the sun is not supposed to look blue in outer space, Wayne. The sun looks white.
It's supposed to be.
The sun look blue.
Well, apparently it likes magenta too.
But blue stars are very young, or supposed to be very young, according to accepted theory, and very, very hot stars. And our sun is not one of those stars. It doesn't emit blue light.
Now I'm going to get it. And it likes magenta too, so it's got some really good taste.
Light. I mean, sometimes our sun emits just blue light and sometimes just magenta light.
I just got to tell you, I think that magenta is your color, son. I just don't know. It might kind of kind of clash with your complexion, but why don't you try the blue? I mean, I feel like this is what we got to do. You look so fabulous in that magenta. So, I mean, it's one of those things. So now here it is. This is it, folks, right here. And I'm going to go back so you can see what's happening here. They're turning down whatever it is they're doing here. They have, and I'll have to go back in my archives, I've captured it. They have a complete power station up there that is a quarter of the size of the initial components of the capsules to keep the astronauts in. It's huge. I mean, because whatever they're doing here, Claudia, is taking huge, vast amounts of energy.
Yes,
Look
definitely.
At that. Look at that.
They have to be getting it from somewhere. I doubt that they are able to generate that much energy to power that thing through the technology that we know about.
Yes, ma'am. Thank you. Look at that. It's overwhelming the iris. Now, we just showed you these cameras can look at the sun. It can't look at this.
Exactly.
What does that tell us?
That's because the camera is very close to the source of the light here. I think that's what it becomes blinding, because it's not in the distance. It's not in infinity. It's right there.
It's right there. Look at what it's doing. And the amount of photons it's emitting is incredible, Claudia.
Yeah, it's completely overwhelming the camera.
So what I suspect here is that I think we're seeing a electrical, or maybe it's electromagnetic, I don't know, but I think we're seeing either plasma discharges in here. That's just my take.
Yeah, I think that this thing is able to obviously produce a very, very intensely bright light. But from the surface, it won't look that bright. But when you close up to it, it will look extremely bright. And then it will do something like this. You see, it's yellow now.
Yeah.
And from the surface of the Earth, the sun is supposed to look yellow, but not from outside the atmosphere.
So, Claudia, wouldn't someone on the Earth see this anomaly if this is that bright? Because I can actually see this. The ISS goes across Denver quite often. I catch it quite often at night.
I think so, but maybe that's why they do it over Antarctica. There's no one there to
see it. And there it is. It's like, all right, Jack, go ahead. Ain't no one down there. There it is.
Well, there are people down there, but they have gag orders.
Yep. Well,
so it doesn't matter.
There you go. There's the whatever it is, that is it right there. So I just wanted to show that to the people so that they could actually see that, you know, this stuff goes on, Claudia, and it's
unbelievable, Wayne. What is going on?
I don't know. I'm just trying to see what's going on. We got a full classroom in here.
Wonderful. I
So
hope people are enjoying this.
I don't know. Y'all are enjoying this? So I was wanting to talk to you on one of your papers, Gravity, the Photon Field.
Oh, yes.
Yes. One of the questions I had after I read this, and I had read an article earlier last week, was the problem with gravity is that the fact that, how do you explain gravity when there is a large void? And I read this and I said, well, you kind of really answered the question right here. Photons.
Yes. What I've discovered is gravity is actually a manifestation of a photon. It's actually so beautiful, and it starts with this diagram that I'll show here. You start out with a photon with two particles that are like one inside a photon. It all happens in threes. Two particles enveloped in a photon. When it moves through an electric field, the particles come out, and when that happens, the photon energy manifests into two particles, but each one, there's a three to it. There's the mass, there's the energy, the power source inside it, and there's the clothing, which envelops the particle. That's its gravitational field. It's again three. It's like spirit, soul, and body.
Mm-hmm.
The spirit is the energy, the body is the mass of the particle, and then there's the clothing around it, the gravitational field.
Interesting.
It's so beautiful how it works. And so the gravitational field is actually photons because it's powered by the photon energy inside the particle. And when the particles interact, and they interact through the gravitational field, it's like the clothing on each particle touching each other, then the energy from within is shared across from one particle to the other until they both have the same energy. But there are two kinds of gravitational energies. The positively charged particle, which obviously would have a spin with respect to its I haven't gone into that yet because it complicates it. It has a spin around its magnetic axis in one direction, produces a positive, or I call it a gravitational field, and I call the other one anti-gravity, because in a way they oppose each other. They cause a repelling force between each other. It's like two different magnets. The proton is the north, the electron is the south, and they actually repel each other.
Okay.
And here I show how if two positive gravitational fields come together, then they merge into one. That's how gravity works. That's why two protons attract each other. You see them merging into one. So that's how gravity actually works. That's why the sun attracts the earth. It's because the earth is within the sun's gravitational field, and they interact through it.
How interesting. So before Gene Cernan passed on, one of the things that he had expressed to me when he said, do you really think that there is such a thing as a vacuum in space? And I said, well, that's what we're taught. He said, no. He said, let me tell you what happens when you get outside of a capsule, even the ISS astronauts. He says, you're falling. He said, gravity is everywhere. Mm-hmm. And that's, I think, Claudia, what I learned from this paper here as well. You just reinforced that, is that you could have what you would seem to be having a great void where there's nothing more than the vacuum of space and zero gravity, but that's not true, correct?
That's absolutely not true, unless you may have, say, if two galaxies in the middle between two galaxies, there may be a region where the gravitational field is too low. Don't forget that these spacecraft they are using, what they are using when they're using artificial gravity, they're using vehicles that have to push against gravity. So they produce an anti-gravity field, like the electron field around the spacecraft. And they have to push against a gravitational field of a planet or the sun. And outside the solar system, they have to push against the galaxy's gravitational field. That I think that's the problem they are having, getting a drive that can push against that.
So that kind of reminds me of string theory, isn't it? That there's a membrane between each dimension that repels each, and it's just, but it's enough to keep them joined together.
Yeah, string theory has a lot of possibilities, like multi-dimensions. Most of them are curled up and would not be felt or detected. But the problem with string theory is that there is no way to actually test it.
Well, there is that problem.
Yeah.
Yeah.
But I think the idea that our universe may be embedded in a higher dimensional universe is definitely a possibility.
So if I heard you right on that, okay, so I'm putting it in layman's terms. So when I think of the sun, I think of its force that goes all the way out to the heliosphere, which is nearly out to, I guess it would be beyond the Kuiper belt, right?
Mm-hmm.
Okay. That in the universe that we have actually seen that there are stars that are literally 1,000 times bigger than our star.
That's true, yes.
Okay. And would it then not imply that the larger the star in the mass, the greater the effect?
Gravitational field, yeah.
Yes, ma'am. Yeah.
Absolutely. Because what I actually discovered is that the size of the star has a lot to do with its mass. So if it has more mass, it has a larger core. And if it has a larger core, it generates more energy and therefore a larger gravitational field. So definitely size has a lot to do with it.
Size does matter.
Yeah, but look at this. You see what we have here is an electron. It has an anti-gravitational field. And so it's repelled by the proton field. Most planets and stars, their fields are mostly proton fields, the orange field. So in order, the electron can be inside it, but it's repelled by it. And more energy comes into the system, may be pushed right out, because it's repelled.
Interesting.
So, yeah, although two electrons can combine and form and merge into a larger field. So basically what we need is ships that act like big electrons and can therefore push against the Earth's gravitational field.
Well, I think as you were just talking, then that would make sense. If I'm going to do a program on H3 and some of the impacts of what we found on our moon about H3. But as you were saying that would almost be like you would have an unlimited energy supply.
The thing is, it is not unlimited. It's
Okay.
generated through radioactive decay. So it's fission, or what is basically used in nuclear power stations. So each object, when it is formed, has a certain amount of unstable nuclei that will decay for the next billion years and generate the energy for the star. But it's like a battery, and it will eventually run down. So that's what happens to the stellar cores. They've run out of that energy. So they have no energy. It's like an atom with almost no energy inside it. And guess what happens? When they come close to an object like the sun or the earth, they act like an atom with very low energy, like you see that in the top here of this diagram. The atom on the left-hand side has much less energy than the atom on the right-hand side. So as the gravitational fields touch, the energy from the one with more flows over to the one with less. And this is how the stellar cores are absorbing energy from the other objects in the solar system, just by their very small gravitational fields, but still there's a gravitational field touching the gravitational field of these objects.
Interesting. I love this.
I try to use lots of diagrams to
It helps
explain things.
We like looking at the pictures.
Yeah.
This
but
is interesting.
The pictures I saw from some of the comments I was getting, that some people were finding it difficult to understand the concepts, even though I was trying to show them through pictures. Yeah.
Well, that's because we have to sometimes unlearn what we've learned.
This is very, very different from everything that anybody has ever been taught.
And here's, okay, excuse me.
Sorry.
No.
So this would be an atom. So an atom has a nucleus, and there will be a certain amount of energy in the nucleus. And there will be an electron with energy in it. But basically, because their gravitational fields are in contact, they would have the same, each of the particles in the nucleus would have about the same energy as an electron. They would all have the same, because the gravitational fields touching means the gravitational energy shared. But then a photon comes into that atom, and say the electron absorbs the photon. Immediately, that energy from that photon will be shared throughout all the particles. But and I didn't actually mention this here because I worked it out afterwards. I must still do an article on that. But then as the energy increases, the gravitational repelling force between the protons in the nucleus and the electron increases. So what happens is the electron moves further away from the nucleus. It moves to a higher orbit, or it may actually leave the atom completely. This is how ionization works.
Interesting.
This is how a plasma is formed. Is by an absorption of energy in the form of photon causes electrons to move further away from the nucleus, because the repelling force, the gravitational repelling force, increases.
Would there always, though, be the relationship between the two, or would they?
Yeah, the thing is, why electrons can exist within an atom is because of the electrostatic attraction between protons and electrons, which opposes the repelling force. So gravity pushes it out, electrical force pulls it in. That's why it stays at a definite, a balanced position. It doesn't come too far in, it doesn't go too far out. But when the gravitational energy increases, then the gravitational repulsion gains an advantage over the electric. That's why the electron now moves further away and further away from the nucleus.
And so as I think about a planet, then what I'm actually seeing is basically, I guess, a cohesion of many electrons binding together, correct?
That's right. So what happens with a planet is, it's like a super atom. What we have in the core is lots of atoms, but the heaviest atoms will be in the core at the center of the object. But they will be ionized. That is, there will be less electrons, so they're positively charged, almost like they are protons, because they're all positively charged, densely packed together, all these ions in the core. So that generates a large proton field, and therefore the large overall gravitational field of the object. So it's like the core is like the nucleus of the object. The electrons are pushed out to the outer layer of the object. So there's a whole layer of electrons above the atmosphere of Earth. From the ionosphere upwards, that's where we find the electrons, and these electrons have been pushed outwards from the atoms that are in the core. So it's like a super atom. The core is the nucleus, the outer layer is the electron orbitals.
Claudia, can I ask you, in this case, in this diagram, and let's just say that this is the Earth, let's say this is any spherical object in the universe. Mm-hmm. Would we find a natural decrease at the poles of?
Yes, that's why I started drawing this as a toroidal field.
Okay.
Because it has a lot to do with the orbit of an electron in relation to the magnetic poles. So
interesting.
We have always, and I've discovered there must be structure even in the proton and the electron for them to be positively and negatively charged and to have a magnetic field. So there is actually another particle in there. There must be two particles inside each proton and electron. It must be structure. But I haven't gone into that because I don't want to complicate things yet.
Yeah, I mean, we're just trying to figure out how to walk here.
I have figured that out, but I'm just trying to still explain the overall structure still. But this would be a celestial object. You can see the red is the core. The yellow ellipse represents the energy in the whole object. It's actually contained in every single particle that makes it up, all the protons and the electrons. But I've drawn it as if it's battery.
Okay.
And then there is the solid layers, and the top would be the atmosphere. It gets less and less dense as we move outwards. And then there's the blue one, which would be the outer negative layer. And that's equivalent to an atom having electrons orbiting on the outside of the nucleus. And then there is the clothing. Just like all particles, the clothing is the gravitational field, which I've drawn here as this orange semi-transparent ellipse.
When I think of energy now, you've got my mind going, because energy, it's gravity, excuse me. That gravity, it's outputting energy, right? Gravity within itself cannot exist without it basically producing energy.
Yeah, well, the source of gravity is the photon energy inside each particle that makes up the overall object.
That would make sense. And of course, there's trillions and trillions and trillions of atoms. Yeah.
And the problem, the stellar cores have very little energy. That's why they have very small gravitational fields. That's why huge objects can be so close to the sun and hardly have any effect on it, except pulling energy out of it. Because the stellar cores are so low in energy, when their gravitational field or their clothing touches the sun's clothing, and they have to come very close to have an influence, they start pulling energy out of it.
That makes complete sense, because I know when I think about something getting next to our sun, and let's say it's larger than our sun, I naturally deduce in my mind is that, well, that larger object is going to have an adverse effect on our sun because of its mass. But that's not true. The energy.
It has to do with energy, because if the stellar cores had as much energy as other objects in the solar system, Some of these are so huge that our solar system would have been destroyed long ago by just one of these objects entering it. But that has not occurred because their gravitational influence is very, very small. And they probably start absorbing energy from the sun the moment they enter the solar system. But they actually absorb much more energy when they are inside the sun's corona.
That would make sense.
Yeah.
It's like them having an extension cord.
Exactly. And they don't just pull energy, they actually start pulling matter itself. That's why you get those vortices, connections, where they're actually pulling matter from the sun through those.
Yes, I think exactly. I've seen those, and that's interesting to actually get stellar mass. I mean, that
yeah.
And again, no one on planet Earth has ever had the opportunity to get any stellar mass. But if we could, what could we discover?
Yeah, that's the thing. I mean, it's taken me many, many months of observing the stellar cores and what they are doing to the sun to pray about it and ask God to show me what's going on. And I think, and trying to deduce from what I'm observing what's going on. And I've built it up bit by bit through these observations of what is going on and what is happening. And I've had a little bit of help, like I said, with James McKinney and his observations of comets and the fact that all objects in the universe have a negative outer layer. That was a breakthrough for me because I realized, but all celestial objects are like atoms. They're super atoms. And
go ahead. I'm sorry, Dr. Albers.
Yeah, there I was explaining, I think, about what Newton found out about gravity is correct. His equation still applies. But the gravitational constant, which he said was constant, it's not constant throughout the universe. It's constant for one particular celestial object only. So you have a G constant for Earth, and you have a G constant for this stellar core, and you may have an even lower one for another one. It depends on the energy, the photon energy inside each object.
We're still learning about photons, aren't we?
Yeah, photons are fascinating. That's right, we are. And basically the whole universe is built out of photons. All the energy, all particles in the universe come from photons. All energy is photon energy. And mass is photon energy. And gravity is photon energy.
So everything is a photon.
Yes, everything is a photon. We're living in a light universe. Everything's made out of light.
Young Sheldon was right. You never heard this?
No?
Yeah, well, yeah, you know, the Big Bang Theory.
Uh-huh.
All right, so Sheldon Cooper, they have a series where he's a little child, genius. Mm-hmm. And he's sitting in church, and the Baptist preacher is reading Genesis 1 and 2. Mm-hmm. And so young Sheldon, who is about 9 years old, raises his hand and he says, so what you're actually saying is God is a photon. So, you know, and you know, of course, that's true. It is, you know, God would be a photon.
Yeah, God is light.
Yeah. So
absolutely.
That just tells me that alone, that we haven't even begun to peel the layers of what a photon is capable of and what I think its true structure is.
Yeah, that's right. There's a lot going on inside a photon. But I just wanted to explain about this diagram.
Yes.
Wayne, because what happens is as an object's energy drops, its gravitational field drops. As you can see, this object here has a gravitational field that does not even go out to the edge of the object. This is what happens with stellar cores. And when that happens, the part of the object that's outside the gravitational field, the object cannot hold on to it properly. And it sheds it. It basically cannot hold on to it, so it starts losing it. That's why the stellar cores have been observed to shed their outer layers, because the gravitational field is so small, so weak, that they cannot hold on to this.
Yeah, I can see that.
This debris that just floats around them, is not attracted to them at all, is not attracted to the sun at all, because the particles inside that end up having just no energy whatsoever. They are, however, able to eventually absorb some energy, I think, from the sun, and they may gain over time. It may be possible, because they break up into smaller and smaller pieces until possibly they are able to hold on to what's left through what remains of their gravitational field. And then that will, if it's able to touch the sun's gravitational field, will start drawing energy from the sun. But this is, I think, why the stellar core share their outer layers.
You know, and I never, again, that's what knowledge does. Knowledge opens doors to new thoughts. New thoughts begin with new concepts. That a low gravitational force of a very large object would have virtually no impact, let's say, on Earth, other than having isolated incidences of wherever that reaction would take.
That's right.
You could see it in you could see it in our atmosphere. Many people see spherical objects. They send them to me, and I forward many of them on. Go ahead.
There is definitely evidence that the stellar cores are interacting with the Earth. They didn't just go to the sun, they came to the Earth. Earth has captured some of them. And they do the same thing with the Earth that they do with the sun, because they go into the sun's corona, which is basically the sun's atmosphere. They will do the same thing with the Earth. They will actually come into the Earth's atmosphere and just move across. I mean, I wrote one article where there were two objects moving together, a binary, across the atmosphere, not far from the sun, clearly visible, emitting light. They were so bright and so visible that they had to be in the Earth's atmosphere. They were not meteors, because other meteors just streak through the atmosphere and they impact if they survive the entry into the atmosphere. But these objects were just flying across, and they were in retrograde. They were moving in the opposite direction that the sun would move in. So they had to be inside the atmosphere, because we only see objects mainly moving with respect to the Earth because the Earth is rotating. And these objects were moving in the opposite direction. They couldn't have been planes flying in the Earth's atmosphere because they were bright, they were emitting light. So these were they either were very small stellar cores or stellar core debris moving through the Earth's atmosphere.
So, Claudia, as I think of the Earth and any large object, planet, moons, whatever, that if we're generating this this gravitational field, which we are, would we not have the possibility that as the Earth in this, and I'm looking at this as almost like a static electrical field, that it would actually capture potentially these objects?
Yes, I mean, that's what brings them in, is they are attracted to the energy. And the way the attraction works is through the electrical field. It's not even the gravitational attraction of the sun that moves them, that attracts them. It's the fact that all they have left is a positive charge in their core. They don't even have a negative outer layer anymore. They lose that. But because they're positively charged, they are attracted to the sun's outer negative layer. And that's what brings them in. It's this electrical attraction. And then once they they start absorbing gravitational energy as long. You can see the blue stellar core, how it's
This is one of the most spectacular
yeah.
pictures, by the way, Claudia.
Yeah, that's
Outstanding.
yeah, Scott caught this through his telescope. He took these pictures through his telescope. It's amazing. At least the one on the left.
That is just, when I saw that, it just,
Yeah.
it's one of those that you just go,
This
okay.
was quite a breakthrough, because
Look at
when I
that.
saw this, that was just amazing.
Mm.
And you can see the debris around it.
Well,
This
not
is-
only, go ahead. I'm sorry.
This is part of the striped appearance that it has. This is the material in those stripes that the object is losing. You can see a small section, it's almost round section there at the bottom.
Mm-hmm.
And where it's losing that layer that's forming these stripes. So this is how they lose their outer layers, and it becomes debris close to the sun. And
It's just amazing.
It is amazing, you see, and it just goes to show what I've drawn in those diagrams comes from observation of what these objects are doing. It's just trying to put it together in a holistic form, trying to understand how it works, how putting together the observation with what we know, how putting together the physical principles that would make the whole thing work. That's what I've been doing over months and years.
We have been so conditioned, Claudia, that we have been told that this doesn't exist. Listen, that there is this very order and very systematic, predictable solar system that we live in. And there's no such things as objects coming in, but yet they will at the same time say out the other side of their mouth, well, of course there's asteroids, there's comets, there's meteorites. So what are we segregating here?
That's right. What they don't want people to know is that the Earth is in danger.
Yes.
They don't want to know that the Earth is actually being deeply affected by these objects. They've gone to extreme lengths to hide this system, that what's occurring in the solar system, from us. This is what the sun simulator is all about. This is what chemtrails are all about. They have put in place a system to hide this, because they cannot get rid of it.
No, they cannot.
So they do the next big thing, they hide it. They don't want us to know what's going on. And even as we learn more and more, I've discovered that it goes even deeper than that. I keep discovering more and more facts that they are still trying to hide. And one of them, I think, is how large some of these stellar cores close to the sun are.
When I see this, and I put it into relationship to the Earth, we're looking at something that I would estimate, 10?
This one is about half the size of the sun.
Yeah, so that would be, folks, if we could see that on a horizon, it would fill the horizon.
We probably have objects that are sometimes would look so huge they would fill the whole sky. Yes.
Yeah.
But don't forget, they have very low gravitational influence. That's why they can actually come very close, and we feel just about nothing gravitationally. It's just they pulling the Earth's energy right out of it, and that's causing the Earth to lose its ability to hold on to its own particles as strongly as it was before. And that's causing the Earth to expand, and that's causing the earthquakes, the sinkholes, and the fissures to open up, especially where there are weaknesses already. That's why Africa is breaking up so fast.
Yeah, we're seeing that happening before our eyes.
They will also cause intense storms in the atmosphere. As the stellar cores come into the atmosphere, they form intense low pressures because of the pulling effect on the atmosphere. So you get a large amount of cloud formation and intense lightning and rain. And you also see strange colors in the sky. You'll see the magenta color that some of these objects are emitting. You see this orange because they cannot be coming from the sun. I've seen it myself with my own eyes. We had a huge thunderstorm come by, and I looked at the sky and I said, oh my goodness, the sky looks like this burnt yellow. And the lightning was intense. And the rain, and this is getting stronger and stronger, these effects.
Well, listen, I've asked Damon to come on. He doesn't take interviews. So you see, and I know we've gone way over, but this has been one of these conversations, Claudia, that I think it's important to have. Mm-hmm. When we're seeing in our atmosphere, because the International Space Station is still in our atmosphere. It's not in outer space. It's still in the Earth's atmosphere.
Yeah.
But when we see radical changes in color spectrum from cameras that are on those spacecraft that are up there, you cannot say that there would not be a direct other effect upon the Earth.
That's right. We have to split the two, though, because they're creating these colors artificially, and the stellar cores themselves are emitting these colors. So we're getting the two effects. So when we get these intense thunderstorms and these strange colors, these are actually naturally produced colors by the stellar cores as they interact with the atmosphere and they pull matter from the atmosphere. They ionize it and it produces a plasma around the nucleus, the core of the object. So in a way, they are a little bit like comets in that way. They produce an atmosphere or a coma around their surface.
And by the way,
strange lights.
And I just want to validate that our Earth has hit, we've known this for a long time, by micro comets, micrometeors that literally are punching holes in our atmosphere.
Yeah.
So now when you were talking about the stellar core, it would make sense now why so often people will capture local phenomenon of the sun, of something in the sky, and you could be 100 miles away and never see it.
That's right.
Right?
Because it's a local effect within the atmosphere.
Thank you.
Yeah.
Yeah.
That's right.
And I also believe that you can be on a certain longitude, latitude line that may be more conducive to these objects.
Yeah, they are attracted to energy, don't forget. So they will be attracted to areas where energy from the surface, from the magma is closer to the surface, say. So this is why they will be attracted to volcanic regions. And this may be why they may influence volcanic eruptions. So we get more and more severe volcanic eruptions, not only because they absorbing energy from the Earth and the Earth is breaking up and allowing the magma to come up to the surface, but because these objects are actually attracted to places where there is magma, and they may be attracted to the energy of actually absorbing that material up to themselves.
Makes sense.
Yeah.
And I'm already convinced as well that this, I think it was in 2014, where there was a particular volcanologist that had made the prediction that he said within the next 5 to 10 years that we will see this magma begin to move up on the eastern side of the Ring of Fire. That's us. And what we saw last week in Guatemala, hundreds of people losing their lives, Claudia. It was just...
I know. I mean, they had no warning. Yeah. You see, this is the thing, that the governments wait to warn people and evacuate them, thinking, oh, there will be time, it will not be so bad. In this time, you have to expect the severity of the events to be way beyond what it was before. So if a volcano starts rumbling, don't wait, get out.
Get out. And those poor people, you're right, when those paraplastic flows were coming through, I mean,
that's just
500 miles an hour. I mean,
it's terrible.
You're yeah. Well, we have definitely gone over, but this has been so informative, Claudia. It has just been 90 minutes. I mean, I'm looking at this, I'm going, yeah, it seems like we just started talking.
Yeah. It's been so interesting and so much fun to see what they have up there with the ISS.
Well, there's 10 people who didn't like what we were talking about. The proverbial thumbs
there are
down.
always people that don't like what we talk about because it's the truth. So it actually validates what we are talking about.
Yes, and you and I both know that all so well. And, yeah. So, okay, well, Dr. Albers, it has been a privilege again to be in your classroom. Thank you. Hope I did all right.
Thank you. It was so interesting. You showed me such interesting footage. You have such amazing captures there.
I have them on a file that is duplicated in a safety deposit box.
Wow.
Well, listen, I think that that footage is over 2 years old. Uh-huh. And many people have since become much more aware, much more awake. And when you go back and you show them the archives of that, they become just as we were, slack-jawed when you first look at it, going, well, wait a minute, that can happen. Yeah.
But the thing is, you see, we need to see it often. A lot of people see it, and because the mind cannot comprehend or actually believe that this is actually going on, the first time they're in shock. My goodness, is this actually happening? But 2-3 days later, the mind has sort of pushed that aside because it's just not coping with it. So you need to see it over and over again before the mind can accept it, that this is actually happening.
And I'll tell all the listeners, I'm going to talk to the sun and tell it really ought to get the teal. I think the teal is better. Anyway. All right, folks, we appreciate you. Thank you all for coming in. We'll be back here next Monday night with another great classroom session. Dr. Albers, thank you again. Stay on once we get out of here. And folks, be good to yourself. Remember, it's crazy, but it's okay. Once you begin to understand that crazy is the new normal, it's kind of all right.
Yeah.
It is. All right, folks, we appreciate you. We'll see you again next week. Y'all be kind.